Alarm Inhibit, or output hold as it's called on our CAL controllers, is a very powerful feature. It works by preventing an unwanted alarm activation, perhaps during process startup or if the set point's changed. The alarm is inhibited until a safe non-alarm condition is present in the process, and then from that point onwards it allows the alarm to continue. The user can select individually which of the alarms will be inhibited and which will work normally at all times. Imagine you have a process and you want to maintain it between the values of perhaps 65 and 80 degrees C, and that you want an alarm if it was to go beyond that point. You set your alarm values at 65 and 80 degrees C, and you have perhaps starting the process at 75 degrees, everything would work normally. If the process went above 80 degrees, the alarm would operate. If it fell below 65, the alarm would operate normally, and all would be well. But imagine now you started your process not from 75 degrees, but from 22 degrees, ambient room temperature. Immediately, your low alarm would activate and perhaps shut your process down. You'd never have the chance to get going. This is where the Alarm Inhibit comes in. With the Inhibit function active, the alarm will not actually activate until the process has first got into a condition where it would not be active and then move back into the active condition again. Only from that point onwards does the alarm activate and work normally. The high alarm that you set at 80 degrees C would already be in the non-alarm state as you powered up, so wouldn't be inhibited, but then of course it wouldn't be active either, so that's not a problem. The Alarm Inhibit function does have to be used with care, however. Imagine we'd inhibited our 80 degrees C high alarm. If when trying to fix the process, somebody had turned the power off and then back on again, but the process was still above the 80 degrees C mark, the alarm would be inhibited, and if the problem hadn't been fixed, the process could continue to rise in temperature, but the 80 degrees C high alarm would no longer be functioning. Your process would not be protected. It's imperative to know which of your alarms can be inhibited and which cannot. In a heating application, generally low alarms are better inhibited than high alarms.